Now sometimes you'll be working on a project where the speed of your code matters, and you need to make sure it's performing as efficiently as possible. Maybe you notice that your program is running a little bit slower than you thought it would, and you need to find out what parts of the program are taking longer to run. Now, irrespective of your use case, you'll need to somehow time your Python code. And there are different ways we can achieve this, and I'm going to walk you through a few examples in this video. Now, the first way of timing code that I'm going to show you isn't necessarily the most syntax-friendly way, but what I can say is it's very simple to do. And what we need to do to help us with timing code is import some functionality from the time module. So the first thing we're going to do is import time. Now the method from the time module that we're going to leverage is what is known as perf_counter. And what perf_counter stands for is performance counter, and it's a function that always returns the float value of time in seconds. So when we run time.perf_counter and put parentheses, think of this as taking a snapshot of the time as soon as that method is run. So if we allocate this method call to a variable called start, we know that we're going to store the start time as soon as this code line is executed. We can then put the logic that we want to time. So let's say that we do three simple things. We'll first of all print hello everyone. We'll then call upon the sleep method from the time module and pass in 3 into parentheses, which will mean that the next line will delay its execution for 3 seconds. After there is a pause for 3 seconds, we'll then print hello ? Are you there? So seeing as we've captured a snapshot of the time and stored it in the start variable, and then run through some code lines, we now need to see what the time is after executing the code. So we're going to create another variable called end and set this equal to time.perf_counter with parentheses. So we now have 2 time values that we can compare. So let's now finally print and utilize f strings. We can put f and then inverted commas. We can then put code run in, open parentheses, and then put the variable end minus the variable start to get the difference in seconds. We can then put a colon and format this to 3 decimal places, so we can put 0.3 and then f, and then we can put seconds. Now Python f strings just provide us a faster, more readable, more concise way of formatting strings in Python. And what you'll notice here is that the f prefix then enables us to put curly braces in order to evaluate values that we pass in respectively. I have attached some documentation in the resources section that will explain formatting strings using f strings in more detail. You can see that when I run this code cell, we print hello everyone, there is a slight delay, it then prints hello are you there, and we then print to the screen code run in just over 3 seconds. Now this is obviously a very simple example, but you can imagine putting the start and end variables with the respective perf_counter method call either side of a lengthy function. If you were to execute a code cell and it takes a few minutes, you could walk away, come back, and it will tell you exactly how long that specific function took to run. So it's a very useful way of being able to observe how fast your code runs. So keep this in mind, putting perf_counter either side of the code that you want to time, and then deducting one variable from the other will give you the time difference in seconds. We can also do it a different way using the timeIt module. So if we put from the module timeIt, import the timeIt method. We can then use the timeIt method to time our code. And the way we do this, well, if we first create a function called join_numbers, and simply return a join of numbers which will be joined by a comma, so we can put inverted commas, comma, then the join method, so dot join, and in parentheses we'll put n for n in range 1 million. In other words, join 1 million numbers together. And we'll join this as a string, so we'll need to wrap the first n in the built-in str function. We can now time this function. So if we put result equals a call on the timeIt function, and then put parentheses, we can first of all pass in the function that we want to test, so we can put join_numbers. We can then put a comma, and then we can specify the number which is used to determine how many executions you wish to run on this function. So for this example, we'll simply run this once, so we'll set number equals 1. I can then print time in seconds as a string with a colon. I can put a comma, and then I can access the result variable. When I run this code cell, you can see that we print time in seconds is just over 0.4 seconds. So we've got good feedback here telling us how long the join_numbers function takes to run once. So that's the second example. Let's move on to the third example. We can actually use a magic command in Jupyter Notebook directly, which will time code for us. And all we need to do is use a % symbol to access the magic command and then put time it. Now if we put a single % sign and then time it, this is enabling us to access the magic command in which the code consists of a single line, or should be written at least on the same line for measuring execution time. So for example, if I put %time it, then a space, I can put time.sleep, and we can allow this function to sleep for 1 second. If I now run this code cell, you can see that the code cell is taking a little longer to run than 1 second, but that's because it's looping over this function 7 times and then producing an average runtime for this function. Now we are able to specify how many runs and how many loops we'd like the timeIt function to perform, but more on this in a second. So if I just do another example, let's put the % timeIt and then put the built-in function max, and we'll pass in range with 100,000 passed into parentheses. You can see that this code cell takes on average a few milliseconds based on 7 runs of this function, where each run had 100 loops each. So you get a very good idea as to the average amount of time this function takes. Now we're also able to put 2 % symbols in front of the magic command timeIt. Now 2% signs before the timeIt command is used to measure the execution time of the entire code cell. So if we put %% timeIt and then on a new line, simply copy and paste the code that we had above with our sleep function, but I'll change sleep to be 1 second. I will also print some dashes after the hello, are you there line, just so it separates the code accordingly. When I run this code cell, you can see that we print hello everyone, there's a slight delay, then we print hello are you there, it then does it another time, then another time. In fact, it will do it 7 times, 1 loop each, and you can see that we get an average of just over 1 second to run this specific code cell. Now if I wanted to specify the amount of runs and the amount of loops each run has, I'm able to do this by putting after the timeIt magic method -r, which will enable us to specify the amount of runs. So if I put 3, I can then put a space and then -n, which will enable us to specify the number of loops each run has. So if I put -n, then a space, then 1, this will do 1 loop on each. When I now run this code, you can see that it goes through the same routine, and at the end we get 3 runs, 1 loop each, and it takes on average just over 1 second to run this code cell. So that's a way we can time code utilizing the timeIt magic command in Jupyter Notebook. Now the next example is certainly the most advanced example in terms of timing Python code, but it's very reusable and you'll be able to time any function you want by utilizing decorators, and we covered decorators earlier in the course. So for this example, I'm going to import the time module, and I'm also going to import the func tools module. I can then create a decorator. So if I first of all define a function called timeFunc, and in parentheses pass in a parameter called func, in other words this will accept a function, I can then include a nested function, so we'll put def time_closure. So we're going to be creating a closure inside of this function. I can then pass in *args, **quargs, and we saw this in the decorators section. Inside of this function, I'm first of all going to set a variable called start, and I'm going to set this equal to time.perf_counter with parentheses. So it's going to store the start time when this function is called. I'm then going to put result, and I'm going to set this equal to a call on the function that's passed into the timefunc function. So I can put result equals func, and then in parentheses put star args, comma star star quargs. I'm then going to set a variable called time underscore elapsed, and I'm simply going to set this to another call on the time.perf underscore counter method, and then I'm going to minus the variable start, which stored that start time before the function was run. I then want to print some information to the screen, so I can print, and utilizing f strings once again, we can put function with a colon. I can then put curly braces, and we can access func.dunder name dunder, so the name of the function that's passed in. And we will actually need to make one other change if we're trying to access the dunder name dunder attribute from the function that's passed in, but more on this in a second. We can then put a comma, we'll then put time, and then we will put in curly braces time underscore elapsed. After this print statement, we then want to return the function, so we can put return result. And then outside of this nested function, we're going to return the nested function itself. So we're going to then put return time underscore closure. Now, in order to access the name of the function that we're passing in, before def time underscore closure, we also need to decorate this with @functools.wraps and then pass in the parameter func. Now, the wraps method is a decorator that is applied to the wrapper function of a decorator, and what this does is updates the wrapper function to look like the wrapped function by copying attributes such as dunder name dunder. It would also copy dunder doc dunder, which is the doc string for example, but if we didn't put this line here, we wouldn't actually bring back the correct function name in our print statement. We can now use this decorator by placing the @ symbol and then the decorator's name on top of any function that we want to time. So if we just firstly create a function called my_func, then put parentheses and a colon, we'll then copy and paste the sleep method that we created above. I can then decorate this function with @timefunc, and if I now call my_func with parentheses, you can see that we first of all print hello everyone, it pauses for a second, it then prints hello are you there, and then at the bottom we get function name is my_func, and then the time it took to run this function was just over 1 second. Now I could use the timefunc decorator function for any other function, and it would then perform the timing of that function accordingly. So utilizing decorators can also be a very good way of reusing code to time different functions in your program. So hopefully you found this useful and it's given you some ideas as to how you can time your Python code. Sometimes it's very useful to know how fast your program's running, so you can target the slower performing areas, and this will just allow you to produce programs that perform optimally.